This is session 8BI, and it's identifying insights from your data using AI on IBM Z and making real-time insight a reality. So we'll just give it a couple more minutes and we will get started. Right, we're going to kick off. So first of all, let me introduce myself. My name is Jeff Eggleston. I'm a GSE committee member. Work for IBM. I'm in the technology group, specifically on the hardware for Z as a technical specialist. This session is recorded. In terms of questions, we would like to try and make it interactive. So if you've got any questions, I would like to unmute you and you can ask your questions. So please feel free just to put your hand up as we're going along. So what I'd like to do now is actually hand it over to our presenter, who I'm very honored and privileged to have today, because our presenter is the CTO based out in Poughkeepsie. And I'm going to hand it over to Elpida Santos. I hope I pronounced that correct. Over to you.
Close enough, Jeff, and thank you. Hello, everyone, and welcome. Thank you for joining us today. I'm Elpida Georgatos. I'm an IBM Fellow and CTO for AI on IBM Z. I'm looking forward to this session, having this session with you today. And during this presentation, we'll take a look at AI and the role it will play on Z and Z workloads. And we certainly want to make sure that our clients accelerate their AI adoption going forward to achieve business results and be competitive in their markets. So what I'll take you through today is talk about our IBM Z AI strategy and how we're helping our clients leverage the data to deliver business insights and make better business decisions. We are going to walk through some of the key points of the strategy that we have laid out and the technologies we're focusing on to enable that strategy. But we will also discuss the value proposition for Z through a couple of use case patterns as well. And also, obviously, I'll talk about the AI acceleration that we're providing with our Telum processor in our Z Next servers. So I wanted to start this presentation about telling you a little bit about how AI is impacting different industries. And I know nearly everyone recognizes that AI is having a great impact on our society and will have even a greater impact in the future. And here are some data from a couple of studies that really speak to the impact that AI will have on businesses as well as governments, for that matter. And AI is at the center of helping businesses interpret their data and make data-driven decisions. And a lot of businesses had to accelerate their digital transformation in this new pandemic world we're all living in, not only to be able to compete, but to survive. And AI has certainly played a critical role in accelerating that digital transformation and has allowed businesses to not only serve, but even know their clients better in this increasingly virtual world that we're all living in these days. And as you can see on this chart, AI already has an impact across a variety of different industries, from finance to insurance to governments. And studies conducted by both McKinsey and Deloitte greatly speak to the importance of AI in the industries as well as in governments. And I also wanted to tell you a little bit about the impact of AI on revenue. A global survey conducted by the IBM Institute for Business Value with participations of over 6,700 C-level execs in 28 countries across, in 28 industries across 46 countries in 2020 found that AI is an economic accelerator has a notable impact on business revenue. And those that were advanced AI adapters have seen the most increase in revenue gains and improvement in business process efficiencies due to AI. So again, just a couple of examples, first of the impact of AI across different industries, but also the impact that AI can have on the revenue of enterprises. So having talked about the value of AI, now I wanted to talk about AI and Z, right? And focus more broadly on our AI and Z strategy. We're focusing on strategy in two key pillars. First, we certainly want to enable you, our clients, to easily embed AI intelligence into your key enterprise workloads and core business processes to drive better business outcomes and be more competitive in your markets. Our clients can leverage Z's transactional and data gravity to drive real-time AI in business critical workloads for AI-infused insights while even meeting the most stringent SLA requirements. So certainly a key focus of our strategy in this space is being able to allow you to embed AI intelligence into your workloads in a consumable manner with production qualities of service. On Z, we know enterprise workloads like, the best than anybody else in the industry. We understand that a lot of your transactional workloads are very sensitive to latency. And if you are going to really leverage AI and embed AI into those type of workloads, you need very fast response times, as well as the requirement to really scale AI in terms of throughput to allow you to examine every single transaction. And if you look at the bottom of the chart here, you'll see that in order to enable you to do that, to very easily embed AI into your workloads while enjoying, right, the core strengths of the Z platform around reliability and performance and resiliency and availability, we are bringing some of the best AI technology from the IBM side, right? The best of IBM's AI portfolio, and coupling that with a lot of the popular AI frameworks and tooling that you see out in the industry and in the open source AI ecosystem. And we're not only bringing those open source AI frameworks and tooling to the platform, but we're also optimizing them for scale for our Z platform as well. A second pillar of our strategy is all about leveraging AI throughout the Z stack and within our IBM Z offerings to deliver an intelligent infrastructure and really bring unique value to the Z platform. We're leveraging AI for intelligent workload placement, for AI ops to enhance the resiliency of our clients' IT systems. And you can see here in DB2 for learning patterns from your unique operating environments to improve DB2 for ZOS application performance, and also in the areas of security and data privacy to protect your sensitive data and increase the cyber resiliency of your enterprise systems as well. Now, when we put forward this AI vision and strategy for AI and Z, flexibility was a key goal of ours. We understood and we recognize from our conversations with our clients that a lot of your organizations have already made investments, perhaps in training platforms and data lakes that might be, on-prem, but off of Z or on the cloud. And we wanted to make sure that we allow our clients to leverage those investments and bring those investments along and get the most out of those investments in terms of efficiencies, such that the models, the AI models and data science assets that you create and develop off platform, whether that's on our power systems, whether that is on-prem on other servers or on the cloud, such that you'll be able to port those assets and easily deploy them on Z so that you can enjoy the production qualities of service that Z offers, but also run those models very close to the runtimes and applications and workloads and core business processes that you have running on Z to gain certainly scale, performance, security, and resiliency. So while you can train your models on Z, we support, we support this philosophy and also the technologies that we've focused on and targeted are such that they make it easy for you, even if you deploy, if you develop and create your models elsewhere, to be able to easily port those models on Z. So again, our strategy and also as you'll see the AI ecosystem that we build on Z is all about giving you flexibility, giving you the freedom of choice to create and develop your models in any AI framework, including open source frameworks and in any platform, but then having the capability to bring those models and deploy them on Z in a very consumable manner, as I said before, while enjoying the production qualities of service that the Z platform offers. So I know that in a lot of presentations you heard about IBM Z and hybrid cloud, and you've heard a lot about how enterprises are embarking on their digital transformation journey by modernizing their applications and integrating the enterprise systems into the hybrid cloud. And from my view, in addition to application modernization and hybrid cloud initiatives that your organizations are pursuing, AI really needs to be the third leg of that three-legged stool, if you will, of your enterprise strategy. As you open up your applications for modernization and to integrating them into the hybrid cloud environments, also, that is the perfect time to think about the opportunities to modernize those applications by leveraging AI to perform what those applications are doing more efficiently, or to enable, to embed rather AI intelligence into those applications to make those applications smarter. And bringing the latest in AI technologies to IBM Z is a key focus for us to ensure that you, our clients, have the most reliable, secure, and high-performing environment to deliver critical business insights. And as you can see here on this chart, and if you look at this AI ecosystem that we built all the way from the silicon up, you see that we've taken a holistic view of our AI technology stack that we wanted to provide our clients, with our goal here being to accelerate our clients' ability to bring AI intelligence to your IBM Z workloads and provide you with an easy on-ramp to adapting AI on Z. And to do this, we focused on bringing the most popular AI frameworks and tools from the open source ecosystem, such as TensorFlow and PyTorch and Onyx, and really combine that with the best of IBM's AI portfolio technologies, such as IBM Watson machine learning for ZOS, but also Cloud Pak for data. And as you can see from this chart, there's a wide scope of AI ecosystem investments that we have enabled on IBM Z, as I said before, all the way from the silicon up. And this starts with the low-level hardware optimizations that include really our SIMD acceleration that we have in our today's servers. And in the future, this will also include the integrated AI accelerator that will deliver in Z Next with our Telum chip. And going up the stack, we're focused on optimizing software to leverage the investments that we've made in our hardware and in the underpinning layers here. And you'll see that this includes some of the math libraries that really contain a lot of the complex math functions used in machine learning and deep learning. And we're leveraging certainly our vectorization architecture in terms of SIMD to optimize those libraries for our Z platform and our Z architecture. We have also, if you look on this level of the stack, as well as, we are developing AI, machine learning and deep learning compilers that we provide on our platform, such that we can take a lot of these AI models and compile them and produce Z optimized executables, such that, again, we can optimize AI for the Z platform as well. And then if you look a little higher in the stack here around the AI frameworks, again, you will see here that we're bringing a lot of the popular AI frameworks and tooling to the platform, but also we're building in optimization into these AI frameworks and tooling. So not are we only porting this popular frameworks and tooling to our platform, but we're also building in the optimization to help scale and make these frameworks be performant on our Z platform as well. And if you look even a little higher on the stack here, as I said before, we within our own within our own offerings on the Z platform, you will see that we're leveraging AI to help our clients tune their systems better with DB2 AI for ZOS. We're helping our clients, again, manage their systems, but also being able to more quickly resolve issues that arise or have a quicker mean time to recovery with our IBM Z operations analytics offering, IZOA, and also integrating with Watson AI apps, such that you're able to, again, monitor and observe all of your IT systems in your enterprise, inclusive of Z here. And finally, if you look at the top of the stack here, you see IBM offerings such as Cloud Pak for data and Watson machine learning for ZOS. That allow you to really manage the end-to-end AI lifecycle. And also these offerings leverage a lot of the optimizations that we'll be making in the underpinning layers to, again, transparently enable you to benefit from all the accelerations and optimizations that we're adding throughout the Z stack, as I said, all the way from the hardware up. So I wanted to take a few minutes to share with you a couple of use cases and the benefits that our clients are seeing from leveraging AI on Z. And as you can imagine, AI has broad applicability to a wide set of use cases across various industries. And you'll see that with some of the use cases I'll talk about that we have worked with or are working with our clients, both on the Z side as well as the Linux One side. So I think it's to no one's surprise that, fraud, and especially with the dramatic increase of online transactions during this pandemic, the cost of fraud has also been increasing, especially, in online transactions. And our clients are constantly looking for finding ways to detect fraud in real time, and therefore make sure that the risk exposure in terms of fraud and how much fraud will cost the bottom line to their business is minimized. So I wanted to start with an example, which I think it's to no one's surprise that fraud detection is a very common use case for Z workloads, especially since a large segment of our clients is in the financial services sector. So what you do see here, we've worked with a large North American bank, and this particular bank had started their journey about 2.5 years or so with actually having fraud detection service on ZOS that was making a call out to a platform that was off of Z in order to be able to score their credit card transactions as part of their credit card authorization process. And what they quickly found out was that that particular architecture wasn't meeting their SLAs. They were having inconsistent response times. They were having a lot of timeouts. Wasn't easily, wasn't able to easily diagnose whether these timeouts were due to network overhead or whether they were due to, issues on the server on the other side. Many times they would have to let the transaction complete without having the benefit of AI. So they came to us and they asked us for help to help them leverage AI on the Z platform close to the fraud detection application that they had running on ZOS that was today based on business rules, but they certainly wanted to leverage AI to increase the accuracy of their predictions and to increase the accuracy by which they could detect fraud during the card authorization process. So they brought an XGBoost machine learning model that they had created off platform, deployed it on Z, and they were very happy to see, consistent response times of 2 milliseconds on the Z platform. Also, another challenge that they had was when they were doing these calls off platform, they had to selectively choose which set of transactions they could score and examine because it can only scale up to 1,200 transactions per second. When they brought this model over to Z, they were able to go up to 15,000 transactions per second. And again, in the future, they're looking to grow and scale to tens of thousands of transactions per second. So again, this is actually a trend we're seeing, not only with this client, but with other clients as well, both in the banking, but also in the credit card industries in terms of challenges that they have with deploying AI and how we have helped them solve those challenges on Z, leveraging the core strengths of our Z platform. But also when I talk about the AI accelerator that would be part of our ZNext servers with our Telum chip. And I know many of you might have seen the Telum announcements. We recently won a CES Innovation Award, by the way, for our Telum chip. And you've seen that there was a lot of innovation done there, and particularly in the AI space. A lot of these conversations that we have with clients and their challenges with deploying AI in enterprise workloads in particular drove, right, there were the key design principles that drove the design of that AI accelerator that you will see being delivered in ZNext and is on our AI Telum chip. Now, the first use case I talked about was an online real-time in-transaction use case. This clearing and settlement use case is a batch use case, a batch workload, but nevertheless, our client here still wanted to make sure that they can leverage AI without elongating their batch window. They wanted to leverage a deep learning model in this case to identify high risk exposure transactions. So transactions that had a high risk exposure and being able to mitigate those so that those trades or transactions are settled in time. So again, here, the technology that they leveraged here was bringing the model over and serving it in TensorFlow serving, which is an open source AI framework. And they did this in ZOS container extensions. So they leveraged the ZOS container extensions to run their TensorFlow serving framework that they use to serve their models, and then have a REST API call from their ZOS clearing and settlement application out to this model. Again, here, very happy with the response times and throughput that they got on the Z platform, but also the fact that they were able to run these models very close to their ZOS applications and enjoy the security and the resiliency of our platform as well. Now, the next few use cases, they're not what I will call, the traditional use cases for our platform. And we're very happy to see that our clients are leveraging AI, in a whole spectrum of different use cases. We're working with a provider that provides services to a lot of state agencies in this use case. And they're scanning, drone aerial images of buildings and plots of land, and they're looking for, modifications or additions to homes in this case to use for tax assessment purposes to make sure that homeowners, are assessed accurately in terms of the property and land taxes that they need to pay. Now, this particular use case leverages Watson machine learning on ZOS. Watson machine learning on ZOS is an offering that we have that basically we took the Watson technology and tailored it for ZOS environments. So it makes it very, very easy, even out of existing COBOL applications, to invoke machine learning or deep learning models to leverage AI to make better business decisions. Another example here is a large North American bank had their customer data in IMS. They wanted to leverage machine learning to be able to very quickly approve or reject loan applicants. And again, here, leveraging some of the capabilities that we have on the platform allowed them to do that. This particular example is an example of how a state government in the US, a state agency, was able to introduce efficiencies into their processes and automate their processes, business processes, leveraging AI. This particular agency had a lot of claims that were coming in, and they were manually being processed by their auditors. They leveraged Watson machine learning on ZOS to be able to flag fraudulent claims and then have their auditors really focus and do deep dives on the claims that would flag as fraudulent rather than having to sift through every single claim. This is another use case in our HyperProtect virtual server environments on the cloud that is really leveraging not only the HyperProtect virtual server environment in terms of being a confidential computing environment, but also leveraging federated learning, which is a technology that's part of Watson Studio and Cloud Pak for Data. With the rise in retail crime, especially during the pandemic in the US, a lot of the retailers wanted to be able to collaborate so they can help each other recognize new patterns in organized retail crime, but not necessarily share the customer data. So they leverage federated learning technology from Watson Studio to be able to build an aggregate model that would benefit from sharing, weights of the particular models of each of the participants and sharing metadata rather than the data to build this aggregate model. And then each of the participants, retail participants, would deploy this aggregate model into the HyperProtect virtual environments, and then that would enable them now to detect not only patterns that they knew about, but also patterns in retail crime that other participants were seeing. So they all benefits from their combined and aggregate knowledge. And lastly, I want to, close my session, my discussion around use cases with a use case that we're working with a large health insurance company in the U.S., where again here they're using our Linux One systems and they're scanning medical images to assess, patient and make patient diagnosis here, and also for some genomic use cases as well. So I hope, I gave you a high level overview of the broad spectrum of AI use cases that we're seeing on our IBM Z and Linux One platforms, and the benefits that our clients are seeing from leveraging AI on IBM Z. Now I want to spend a couple minutes. I know you might have heard a lot about Telum processor and the AI integrated accelerator embedded on that Telum chip that would be delivered with our ZNext servers, but I wanted to spend a couple minutes and talk about that. And I know many of you have seen the announcements around Telum processor and our integrated AI accelerator. And many of you might have recently seen, the press from CES and the award, the CES Innovation Award that we received for this chip, which I'm very, very excited about, by the way. So as I said before, we've designed this accelerator for low latency, high throughput workloads. So you, our clients, can leverage AI in real time in workloads that have the most stringent SLAs, such as real-time in-transaction inference for your transactional workloads. With our Telum AI accelerator, we're enabling you to bring the state-of-the-art deep learning inference even in the most latency sensitive, most demanding real-time workloads, giving you the ability to examine every transaction. And as I said before, what really drove the design of this accelerator was really the examples that I've talked about just before. And again, the discussions that we had with clients like yourselves about some of the challenges that you had with operationalizing AI in general in enterprise workloads. In addition, right, we wanted not only to design this accelerator to meet your today's needs, but we wanted to make sure that we anticipated your future needs and that it would allow you to scale and being able to embed AI in every transaction, and not only today, but also in the future. And just a little bit more detail here about the accelerator. A couple things that I want to highlight. One is not only are we accelerating some of these very complex math functions and operations that are part of those inference models and the computations that they need to do in order to come up with a prediction, but also part of the performance that we're seeing here and part of the designing this accelerator to serve real-time use cases was about that this accelerator was on the chip. It shares the memory and the level 3 cache with the general cores on the chip. And unlike other accelerators that you might see in the market, like GPU accelerators, where you have to transfer the data that the computations need to be done on from main memory down to the memory of the device, like the GPU card, here, right, these AI accelerator can directly act on the tensor data because it's in memory and it's also in the level 3 cache that's being shared with the general cores. So we actually, that is one of the key design points that allows us to have very, very fast response times, especially for real-time use cases. Just, for the geeks out there who really want to see the design of the accelerator, you can see some more details here and some stats. You can have over 200 teraflops horsepower on a full 32 chip system. You can see here in terms of the accelerator itself that you can have up to 128 SIMD engines. The process, operations such as matrix multiplication and convolution. And then we have another 32 additional SIMD engines that are really dedicated to optimize activation functions and complex operations such as sigmoid and so forth. So really a very powerful accelerator. And again, one thing that I want to highlight here is knowing that how fast evolving this deep learning, and AI space is, we made sure that this accelerator is easily extensible, such that if new, complex math operations come into view in terms of some of these popular, deep learning algorithms that are being leveraged out in the market, we can easily add acceleration for such functions through microcode or picocode to this accelerator as well. So extensibility, was really woven into the design of this accelerator as well. Now, as I said initially, when I showed the whole AI ecosystem, we really, from an AI strategy and vision point, build this AI acceleration in the hardware with the notion that an end user should be able to transparently benefit and inherit the acceleration that we're adding, both in hardware and software and software layers. So here you can see that we're building a backend to popular AI frameworks such as TensorFlow, and I'll show you some more detail of this in the next couple of charts. As I said before, we're optimizing a lot of the open source libraries such as OpenBlast and Eigen to leverage a SIMD acceleration for a lot of these machine learning algorithms. We're also introducing a new library to be able to leverage the acceleration that we're providing on our AI inference accelerator, or AI unit, as we call it, on the Talon chip. And you'll see a lot of the details on that, how really the vision here was, from an end user perspective, we wanted you to be able to leverage common skill out in the industry, deploy your models, whether they're machine learning or deep learning models, in the same way, with the same tooling, with the same frameworks as you do anywhere else, but then transparently, again, inherit the acceleration that we're adding into the hardware and software layers of our stack, and have better scalability, reliability, and security on our platform, while leveraging common industry skill and tools to deploy AI models into your applications and workloads. Here, a little bit more detail to show you some of the magic that we're doing and the different layers that we put into the stack. In this particular example, I'm showing a TensorFlow. So let's say an end user is deploying using TensorFlow, serving a model, right, a deep learning model that would be invoked by their applications. And this deep learning model is using a linear algebra matrix multiply operation. We're building, you can see here, this green part of the stack, a backend, a device plugin to TensorFlow, such that if our clients are leveraging TensorFlow to serve their models, can, again, transparently leverage the acceleration that we're providing in our ZNext servers. And that backend would invoke this ZDNN library matrix multiply operation. ZDNN, you can think of it as analogous to CUDA-DNN. It's a software library that has all the operations that our AI accelerator here at the bottom would accelerate. It will issue this new neural network processor assist instruction that we're adding, and it's part of the embedded AI accelerator for the on the Telum chip, and with the function code of matrix multiply in this case, and that function would be again routed to this AI unit or the AI inference accelerator on our servers and be again accelerated. So again here, this shows you how we really have put a lot of thought into making sure that the end user, at the end of the day, can very easily benefit from this acceleration without having to make any changes. And the idea here is if clients that I talked about, in the use, when I talked about use cases that have AI deployed on Z today, when they upgrade to the Z Next, they can push and pull the machine without having to make any software changes and transparently benefit from the acceleration that Z Next will provide with the AI integrated accelerator. And now let me talk about a couple key technologies we have invested in to make sure that, as I said initially, you can very easily, no matter what framework, right, you use to develop and create your models, and no matter the platform, you can easily operationalize AI and when you embed AI into your applications and workloads and core business processes on Z. I talked a lot about TensorFlow, and the reason we've chosen to optimize TensorFlow on Z is because it kept coming up, again and again in our conversations with clients in terms of being a very popular AI framework that they use to both train and also serve and deploy their models. So it was important to us that not only we had TensorFlow available on our platform, but also that we optimized it. And as you saw in the previous chart, I showed you how we're optimizing TensorFlow to also leverage the accelerations that we put in our software stack, but also our Z Next AI hardware acceleration. Now, TensorFlow is available today from our IBM container repository, container registry imaging, which is a trusted and curated channel where we provide a lot of open source containerized images, including TensorFlow and a lot of the other AI frameworks as well. And it can run in any of our Linux environments, Linux One, Linux on Z, as well as IBM Z OS container extensions, which is again and a Linux-like environment that's running directly on ZOS, where you can bring Linux-like containerized workloads and AI frameworks that will run directly on ZOS. And we've seen quite a few clients leverage ZCX to actually deploy their AI models very close to their ZOS applications. This chart shows you a very quick example, right, of how even out of existing COBOL application, clients can leverage, with a REST API call, can make a call out to TensorFlow and to an inference model being deployed in TensorFlow serving to take advantage even, for state-of-the-art machine learning and deep learning algorithms into their ZOS workloads. Now, I wanted to talk about another path, which I think is also very interesting in terms of optimizing AI on our Z environments. And you can see here that there's a plethora of frameworks which clients can choose to develop and train their models on the left-hand side here. And obviously, I said how we optimize TensorFlow, but then there's many others that are being used out there in the industry. PyTorch is another popular one. And the way to really optimize models that have been created by these other frameworks for our platform was to leverage Onyx. Onyx is an open source project under the Linux Foundation. It's a format, open standard for representing AI models. It's an exchange format for representing AI models, and it was really created with the goal of portability of models in mind. And that was because even out in the industry, some models that data scientists used are more efficient for training, others are more efficient for serving or deploying those models. And the idea here was that data scientists can choose the AI framework of their choice to develop their models in without having to worry about the downstream effects of of the environments that these models were going to be deployed in. And Onyx allows for many different backends so that you can optimize those models so they can be created in any AI framework, right? The data scientists can be free to choose and then have the capability to have plug in, different compilers and different runtimes that can optimize for different platforms and architectures. So certainly a lot of the AI goals and where Onyx is going and where that project and community is going aligns very, very well with our AI vision and strategy. And we leverage Onyx to deliver on that vision of being able to give our clients the freedom of choice to develop their AI models and data assets on any framework and on any platform, but then being able to easily optimize them and deploy them on Z. So we developed the IBM Deep Learning Compiler that would take a model in the Onyx format, compile it, and produce a Z-optimized executable inference program that can be evoked from applications for leveraging, machine learning or deep learning models. Now, the neat thing about this path is that even in environments such as TPF that might not support, any of the frameworks that you see on the left-hand side here, by the time you leverage the deep learning compiler and you have, this inference program, you can directly deploy and leverage AI even in those environments, because this inference program that gets generated by the deep learning compiler no longer has any dependencies on the libraries or frameworks or heavy tool chain that you see here on the left-hand side. So to me, this is a very key capability here. And here is another example where, again, I'm showing from a ZOS perspective how easy it is to be able to leverage Watson machine learning for ZOS in this case, to be able to make a call to machine learning or deep learning models from existing COBOL applications with a couple lines of code. Just a link to the inference engine in Watson machine learning is all it takes. And then, you can leverage machine learning and AI models right from your COBOL applications.
I just want to let you know you got 10 minutes and you're doing grand.
Yeah, I should be good here. Thank you, Jeff. Yep. And by the way, let me take a pause. And do we have any questions so far?
We've had no questions at the moment. I would have interrupted. Okay. So anybody got any questions, please?
All right.
Okay. So there's no questions. So carry on. Thank you for giving the opportunity.
Okay, sure. So I also wanted to talk about a key capability that we're adding to DB2 in the future as well, to DB2 Next. And I want to ask if any of you are interested in participating in a sponsored user program for this particular capability. Please feel free to reach out. Now, what we're doing here is we are extending, the capabilities of existing DB2 applications to be able to issue semantic queries. And what do I mean by that? And we're leveraging AI to do that. What I mean by that is now you can use SQL to match on the semantic meaning and value of data within your DB2 tables, rather than, with today's SQL, you need to match on exact values. So what we're doing is right into the DB2 engine, we transparently providing AI by transparently training a neural network model on your DB2 database data and building a vector table of the semantic meanings of that data to help you with, simple SQL queries, detect patterns between the data, hidden relationships between the data, and we're, again, you don't have to be a data scientist, you don't have to do the model training, because that's all done under the covers transparently. We'll train the model on your DB2 data, as I said, build this vector table, and also provide you with a built-in semantic query functions such as clustering and similarity. And the simpler way for me to explain this would be, in the past, you can use DB2 SQL database to get reports and so forth. Now you can ask your DB2 through the SQL queries to help you make decisions. With the similarity queries, you can ask things such as, if I have a set of wealth manager or one wealth manager that has done well, what other wealth managers have done similarly well, or which wealth managers have not done well that perhaps you can help by giving them some guidance from this one wealth manager that has done well. If you wanted to detect patterns, fraud patterns, for example, in your data, if you knew of a particular fraud pattern, you can ask through semantic SQL queries, what other transactions have similar fraud patterns. Or for example, if you knew that certain transactions were valid and were not part of a fraud, you can ask, what other transactions are dissimilar? Meaning, if they're dissimilar, then there might be fraud in those transactions and so forth. So you can use this, now you can use SQL queries to help you make decisions and really detect hidden relationships between the data and that you have within your DB2 database. And again, if any of you are interested in being part of a sponsored user program for this DB2 capability, which we're calling DB2 SQL Data Insights, please feel free to reach out. I'm going to skip that chart. Just wanted to make sure that you are aware that we have this IBM Z container image registry, which is a curated and trusted channel where you can go out there and pull a lot of these open source containerized images, and they're available for you. As I said, TensorFlow is one, but there's many others out there, and you can just grab them and pull them into any of our Linux environments, whether it's Linux One, Linux on Z, or ZCX, ZOS container extensions on the ZOS side. And I wanted to conclude by letting you know that we have an IBM Garage for Systems workshop that is free of charge that you can take advantage of. It consists of many different modules. We do have an AI maturity assessment that tool that you can take, and depending on where you are in terms of your AI journey, we can really start this workshop at the specific module. For example, if you want to start to have a brainstorm about thinking about AI use cases and how AI can benefit your enterprise, and then move on, to the technologies that you can deploy to help you implement that use case. And then if you wanted to get hands-on experience with TensorFlow or Watson machine learning on ZOS and so forth. So we have quite a few modules to this workshop, and taking the AI assessment will help us make sure that we start you at the right module based on your existing skills and knowledge. For example, if you already knew what use cases you want to leverage AI for, but you wanted some hands-on experience, we can certainly start you there. So again, free of charge. If any of you are interested, again, feel free to reach out. If you look at the chart deck, there are many other additional resources where you can go and find out additional information about AI on Z. And again, I'm going to end the session here. Thank you so much for your time. And as always, you can go out there and give us your feedback on the session today. We do have 4 more minutes or so. So if you have any comments, feedback, I certainly would like to hear your perspective on this.
Well, Peter, I thought that was awesome, but for me personally, I love the holistic stuff that you mentioned, but more particularly, I was quite surprised when you mentioned the clearing and settlement example. It's all done in batch. As somebody who has actually come from a batch environment, I thought that was very good. But the last example you gave, I think it was the last one. No, it was the second one. The aerial, the drone, where they actually look at the houses and see if they're big for the councils. I thought that was a bit scary, to be honest, a big brother, but it's really good. But no, a very, very good presentation. And as you've mentioned, feedback, if you go onto the agenda, click onto the forum that actually got you this link, at the bottom there is also that link, and the session is 8B1. And again, if you can consider the 2 charities that GSE are supporting, namely the blind, for the dogs for the blind, and the RLNI, which is the sort of lifeboat, that'd be awesome. I don't have anything more to add unless anybody else does. In that case, I am going to thank you once again for a fantastic presentation, and I'm going to bring this to a close. And thank you very, very much.
Thank you, everybody, and thank you for your time. Thank you.
Okay, cheers.